Chemical reactions or chemical changes are several types. One is chemical combination. The chemical reaction in which two or more substances they combine and give a single product is called chemical combination. The chemical change in which two or more reactants they combine and give only one product, a single product, is called chemical combination. For example, calcium oxide reacts vigorously with water and gives slaked lime. So, CaO, solid calcium oxide, so called quick lime, when reacted with water, this water slices the CaO. It makes the solid into slices. This is called slaking of lime. Slaking of lime. And the product calcium hydroxide produced is correctly called slaked lime. And this slaked lime, if it forms as a thick white precipitate, it is called milk of lime. It is used for whitewashing. And the solution above this thick paste, white paste, this solution, a clear solution, is called lime water. It is used to detect carbon dioxide gas. Hence, CaO with water, two reactants giving only one product, CaOH twice, correctly called chemical combination. Similarly, burning or combustion, burnt in excess air. So, carbon solid, that is coke, burnt in air, it gives CO2 gas. So, two reactants giving only one product, chemical combination. Similarly, hydrogen gas with oxygen gas forming a single product, water, that is chemical combination. Nitrogen gas and oxygen gas during the time of lightning, which supplies energy. So, with that energy, these reactants they combine and they give single product, so called nitric oxide gas. So, the gas formed in small amounts during the time of lightning is nitric oxide formation, is a very good example for chemical combination. Chemical decomposition, the chemical change or the chemical reaction in which a single substance, so called reactant, gives two or more substances, so called products, is called chemical decomposition. For example, hydrogen peroxide decomposes slowly and gives water and oxygen gas at room temperature. This decomposition is very faster at high temperature. And platinum, manganese dioxide, these substances, they act as catalysts. They speed up the decomposition of hydrogen peroxide into water and oxygen gas. Similarly, metal carbonates on heating undergo decomposition to produce metallic oxide and carbon dioxide gas is liberated. So, here one reactant, metal carbonate, giving two products, metallic oxide and carbon dioxide gas, is so called chemical decomposition. For example, limestone CaCO3, which is a solid, on heating undergoes decomposition and gives CaO, so called quick lime, in solid state, and carbon dioxide gas is produced. So, one reactant giving two products. Carbonates of sodium, potassium, rubidium, cesium, they are thermally stable. they do not undergo decomposition on heating. They are thermally stable. That means Na2CO3 sodium carbonate, when it is heated, no decomposition as such, thermally stable. Silver carbonate, on heating, it gives a solid residue of silver metal and carbon dioxide, oxygen gas are liberated. Here Ag2, 2Ag, CO3, CO2 is out. The remaining O is coming out as of O2. Equation is balanced. Similarly, sodium bicarbonate, solid, on heating undergoes decomposition and gives sodium carbonate solid, water in liquid state and carbon dioxide gas is liberated. Here Na2, 2Na, 2H, H2, 2O3, 6 O's, here 3 O's, here 1 O, here 2 O's, totally 6 O's. Equation is balanced. Very good example for chemical decomposition. Ferrous sulfate crystals, that is hydrated ferrous sulfate, commonly known as green vitriol, on heating loses water molecules. This 7H2O is out. Left out is FeSO4, ferrous sulfate. On further heating, this ferrous sulfate, FeSO4, undergoes decomposition and gives ferric oxide, sulfur dioxide gas, sulfur trioxide gas. So, one substance, that is reactant, undergoing decomposition to 3 substances, so called products. Here Fe2, 2Fe, 2S, 1S here, 1S here, 2O4, 8 O's, here we have 3 O's, here we have 2 O's, 5 O's, plus 3, 8. Equation is balanced. Likewise, metal chlorates on heating undergo decomposition and give the corresponding metal chloride and oxygen gas are the products. Metal chlorate gives metal chloride and oxygen gas. Here we have O2, here we have O3. To balance the coefficients, 2 3's are 6 O's, 3 2's are 6 O's, balanced. Then 2Cl, 2Cl, 2M, 2M. Equation is balanced. On heating, potassium chlorate, KClO3, undergoes decomposition and gives a mixture of KCl and O2 gas. So, one substance becoming 2 substances, decomposition. Likewise, lead nitrate, PbNO3 twice, on heating undergoes decomposition and gives a mixture of lead monoxide, oxygen gas and brown fumes of nitrogen dioxide gas is liberated. So, NO2, it has brown coloration. In presence of sunlight, substances such as silver chloride, silver bromide undergo decomposition and give silver metal. So, 2AgCl gives 2Ag plus Cl2. Here Cl2 is there. So, to balance this one, 2Cl's, 2Ag. Similarly, 2AgBr gives us 2Ag plus Br2. Actually, this silver bromide is used in photographic films. Hence, that films are loaded even in camera in the absence of sunlight. Otherwise, silver bromide present in the film undergoes decomposition. In presence of zymase enzyme, glucose or fructose undergoes decomposition. That is one substance, glucose or fructose, undergoing decomposition and gives ethyl alcohol and carbon dioxide gas is liberated. Very good example for decomposition. Of course, this decomposition is called fermentation. Chemical displacement, the chemical change or the chemical reaction in which an element of a compound, that is reactant, is substituted or replaced by some other element, is called chemical displacement. Here metals like iron, zinc, lead, they are more reactive than copper metal. Hence, this metals displaces copper metal, is out and Fe is in, Cu is out, displaced. The product is FeSO4, ZnSO4, PbCl2. In all the cases, these more active metals Fe, zinc, lead displaces less active copper metal. Best example for chemical displacement in which more active metals displace less active metal. Similarly, iron metal with red hot steam, it displaces hydrogen gas, results in the formation of iron oxide. Here Fe plus steam gives us Fe3O4 plus H2, Fe3, 3Fe, O4, 4Os, 4H2Os, 4H2, 4H2. Equation is balanced. When zinc granule is dropped in aqueous solution of sulfuric acid, hydrogen gas is liberated, displaced. The remaining product is ZnSO4. Equation is balanced. Double displacement. Such reactions in which an exchange of ions between the reactants are called double displacement reactions. For example, here cations, sodium ions, anion, sulfate ion with the charge -2, two sodium ions, each sodium plus 1, two sodiums plus 2. When this aqueous solution is treated with barium chloride, each chloride is -1 charge, anion totally -2, and barium is cation plus 2. So once barium chloride aqueous solution is added to sodium sulfate, this sodium ions with that chloride ions. So 2 NaS 2 Cls as 2 NaCl, and now this barium ion cation with this sulfate ion, it gives barium sulfate, which is not soluble in water, insoluble in water, hence it comes out as precipitate. So exchange of ions, this cation and that anion, this anion, that cation, correctly called double displacement reaction. Similarly, Na plus, Cl minus, Ag plus, NO3 minus, this cation and the other anion, and this cation, the other anion, we have AgCl, a white precipitate, plus NaNO3. Similarly, NaBr with silonitrate, +1, -1, +1, -1, this Ag plus 1 with Br, we have AgBr, yellow precipitate, and NaNO3 is the product. In these reactions, the products barium sulfate, silver chloride and silver bromide, they are not soluble in water. They are insoluble in water, hence they are getting settled down at the bottom of the test tube. These reactions are called precipitation reactions, which are very good examples for double displacement reactions.